Hello everyone, this is NEET Edge, and in today's video we will be solving an important question of the chapter Modern Physics. So let's start. The question says, the distance of closest approach of an alpha particle fired towards a nucleus with momentum p is r0. When the alpha particles are fired towards the same nucleus with the momentum 5p, the distance of closest approach will be. So in such questions, the main concept that is used is energy conservation. So let's see what the question says. Here, there is a nucleus and an alpha particle which is initially very far away from the nucleus, because of which its potential energy is zero and it contains only the kinetic energy, is fired towards the nucleus. So as the alpha particles comes near to nucleus, it experiences a electrostatic repulsion because nucleus contains nucleons and protons. Protons consist of positive charge, and helium plus 2, that is alpha particle, is also positively charged, and we know that the like charges repel each other. So the more closer the alpha particle reaches the nucleus, the repulsion become more and more stronger, and there will be a point at which the kinetic energy of the alpha particle will be completely converted to potential energy. At this point, kinetic energy will be equals to potential energy. We know the formula of potential energy is K Q1 Q2 upon R. Here Q1 and Q2 are the charges of nucleus and the alpha particle, and R is the distance of closest approach. So kinetic energy will be equals to K Q1 charge of alpha particle, that is 2e, into Q2 is the charge of the nucleus. As we don't know the atomic number of the nucleus, so let it be Z E upon R. Now we can see that K, 2, E and Z are constant, so kinetic energy is inversely proportional to R, that is distance of closest approach. Now there is one more relation between kinetic energy and momentum, that is kinetic energy is equals to p square upon 2m. So we can say kinetic energy is directly proportional to p square. Now by using these two relations, this first and second, we can say that distance of closest approach is inversely proportional to p square. Now in the questions, there are two cases given, that initially the momentum was p and distance of closest approach was r0, and in the second there the momentum was 5p and distance of closest approach we have to find out. So by using this relation, we can say that r initial upon r final is equals to p final upon p initial whole square. R initial was r0, r final we have to find out is equals to p final is 5p and p initial was p whole square. P cancel out, 25. So R0 upon 25 is equals to R final. So we got R final as R0 upon 25. So fourth option will be the right answer.